star, Cleveland's own Sultan of Secularism and Science.
That's the most elaborate introduction I've ever Can you hear me at the back?
Yes.
Okay, terrific. Because I prefer to stand up here. So, just in case some of you don't know, today was a pretty significant day. President Obama announced that he has come out in support of same-sex marriage. And I think that's still a long way to go, considering what happened in North Carolina and places like that. But it's a very significant event, and I think it all goes well for the future, because I think in terms of, I've always felt that religion is a negative influence, and one of its most negative influences is the way it treats the gay and lesbian community, and that has to be broken. And I think this is a good first step. So anyway, today I'm going to talk about how the age of the earth became a religious issue, and it's also the universe, but not so much. By the way, I like people to just interrupt me whenever you want to. Don't have to wait till the end. If there's anything I'm saying that you would like to stop and get me to elaborate or challenge or something, please feel free, and we'll discuss it, because I know that it's not very interesting to just sit and listen to someone for a long period of time. As a teacher and educator, I know that people's attention starts wandering after about 10 minutes, if you're lucky, as a teacher. And so it's useful to break it up with questions and discussions, because that enables people to get their interest back up. So feel free to interrupt me whenever the mood strikes you. Okay. So here's the short version of the story. Oh, no wonder it's not working. I've got to put the antenna in.
Shorter than you expected.
Yeah. So the Earth used to be considered really old, even possibly infinitely old. That was what people thought at the beginning. Then it became really young. That was around 1600 AD, or CE as I prefer to call it. Okay? Then it became kind of sort of old again. Not infinitely old, but old, around 1800. Then it became kind of sort of young again, around 1900. Then it became really old again, except for those people who are still stuck at stage 2. And we'll talk about them, why that happened later. So that's really basically the story. Now, at first, when you go back in the early days, the age of the Earth was not really an issue. People didn't worry too much about it, didn't try to calculate it and so on. It was just not there. And in the pre-Christian era that I'm talking about, it just wasn't such an important question. And there were various theories that were put forward at that time. All kinds of people had cosmologies of the origins of the Earth and universe and so on. And one of them said that, okay, it's been there for an infinitely long time, which kind of made sense. The Earth looks like a very permanent place. Other people said, well, there was repeated cycles of creation and destruction. And you can see where that idea comes from too. You get the annual seasons, you get the spring and the fall, summer and the fall, and then the winter and then spring again. The idea of a cyclical process also made sense, so people thought it may be like that. But Christianity, the arrival of Christianity actually changed everything. With Christianity and Jesus, it required a single creation with a definite being. Okay? Because, for one thing, with Christianity, the idea of cycles got thrown out the window. Because if you had the idea of Jesus coming and being sacrificing his life for us to atone for our sins, that had to be a one-shot deal. It wouldn't make sense for Jesus to keep coming back every so often and being crucified again and again. You have to have a one-shot deal. So suddenly this cycle business for Christian communities didn't make much sense. So then when people started asking, so there's a single one-shot deal, when did it happen? Okay? And there are people again, the only thing they really had to work with was the Bible. And so they looked at the biblical stories and they started thinking in terms of metaphors. So the 6 days of creation in the story of Genesis, they thought meant that creation will last for 6,000 years. There was a relationship that they drew between a day and 1,000 years. And if you look at those biblical verses that I gave, it talks about one day in God's sight being like 1,000 years and so on. So people said, okay, that means that the 6 days of creation is a metaphor for 6,000 years. Okay? And so they thought creation will last for 6,000 years. And that Adam being created on the 6th day meant that Jesus will arrive in the last 1,000 years. So Jesus will arrive somewhere between 5,500 and 6,000 years. So that was the general idea that was driving it. So when people started looking at Bible-based chronologies and tried to figure out might this have happened, and actually the earliest estimates using the Bible went back to Theophilus of Antioch, somebody who lived around 115 to 183 CE, and he put the date of the creation as 5,529 BCE. Okay. Now notice that they thought the creation would last only for 6,000 years, because remember that when Jesus died, he said, I will be coming back soon. And in fact, in the Bible, he said, I will be back before some of you even died. So they were, thinking it's going to happen pretty soon. So, but of course, he didn't come back. And so people about 100 years after his birth, started thinking, well, it's about time. Okay, so if it's 6,000 years, they started calculating back, and so they arrived at this 5,520. So it said that, it's getting pretty close to 6,000 years. So people started getting sort of antsy, Jesus is going to come. Another person, Julius Africanus, also did a calculation, and that arrived at about 5,500 BCE. So again, by the time he was calculating it, he thought it was about 5,700 years have passed. So Jesus is going to be pretty soon. Okay. So after that, there weren't really that many calculations, except around 1600s. There was an explosion of calculations. And it was likely triggered by the possibility that the end of the world was imminent. People thought it was going to happen very, very soon. And the most famous calculation that most people are familiar with was by Bishop Ussher, Bishop in Ireland. And he did this calculation that arrived at the date of 4004 BCE. And although we make fun of Ussher's calculation and sort of make fun of his result, it was actually a very good calculation for that time. I mean, it was pre-modern science, really. I mean, so he really didn't have much to go on. He had the Bible. And what he did was, he looked at the Bible and he looked to see what are the events in the Bible for which there is some independent corroborating date. And the only one that happens is about 562 BCE. The Babylonian king Nebuchadnezzar died that year, and that's recorded in the Bible, and that we also have contemporary secular sources. So that is the one point. If you look at the biblical chronology, everything that happened before that, there is no historical evidence for. None of this, the Exodus and captivity in Egypt and King David and King Solomon, all that stuff, there's absolutely no historical evidence at all. And as far as we know, it's completely mythological. But he took this event, and he said, okay, now we can fix this event in the Bible. And then he went back. And in the Bible, it turns out that there are a pretty good number of chronology of the years of each king, how long he ruled. So he calculated back. Then when the king started getting wiped out, you had all the other, the begats, all those guys. So he started adding all those, and he arrived at this age of 4004 BC. Actually, the original calculations was 4000 BC. But there was some mistakes about the King Herod's time, so it went to 4004 BCE. So he arrived at that number. He may not have been the first person who did this calculation. There was William Lloyd, the Bishop of Worcester, also got 4004 BCE. And there were even some other people who did. Isaac Newton, for example, also calculated. And he used the Bible. All of these people are using the Bible because that's all they had. Okay? Yeah.
How did they come up with such a specific year with such a vague thing as generations?
If you look, if you read the Bible, actually, it's kind of surprising. It's as if the people who wrote the Bible passages, wanted people to do the calculation. Because they would say, for example, so-and-so was born, and he was this age when he had his oldest son, and the son was this much old when he died, and that son's son. So if you I have actually gone down and seen, and you can actually fix from father to son to the next generation, the exact ages are given. It's quite impressive actually. And I always wondered why were they so careful? Because they had to give the date at which the person was born, the day, that person's age when the son was born, and how old the person was when he died. Those three pieces of information are given for each of these people in the genealogy. So you can actually calculate that. With kings, of course, you just had to add up the years which they ruled, and that's also given in the Bible. The catch was different translations had slightly different, there was the Hebrew Bible and the various other Bibles. And Usher, I think some people use the Hebrew Bible because that gave you exactly 4000 BCE. And this idea of one day being 1000 years, they like round numbers. So the Hebrew Bible is popular for that. Yeah.
I'm sorry, where there's gaps, is a generation in the Bible considered a fixed number of years?
No, they actually gave the age of each child.
So there's no gaps?
No. That's why it's pretty boring. If you go, it's just begets after begets. It just goes on. I mean, you're covering thousands of years in this.
If you like crunching numbers, it's a good place to go read.
Yeah. It's terribly boring. But, Usher did a very careful calculation. He really carefully went through this thing. I mean, ever since I read about Usher, I don't make fun of Usher. I mean, the idea of using the Bible, once you accept the fact that the Bible is going to be your source of information, he did a very good calculation. And, he has to be commended for that. Yeah.
Is there any relationship between the year on the Hebrew calendar, which is 5,700 or something, and these calculations for how old the age of the universe?
No, because it doesn't matter which calendar you use, because they were just adding up here. They were saying, you fix the date of King Nebuchadnezzar's death, and then you just count the years. So whichever calendar you use, the years were the same.
But is that number for the year on the Hebrew calendar, is that based on when they think the beginning was supposed to be? The beginning?
No, they were working backwards to find where the beginning was.
But where does the number 5,700 something come from on the Hebrew calendar?
Oh, when did the Hebrew calendar start?
Yeah, is there any relationship between...
I don't know when I don't know where the year 0 was in the Hebrew calendar. Anybody here know? What? No, Christian calendar starts the year 0 with Jesus' birth, right?
No. That wasn't even invented until at least 300.
No, but what I'm saying now, we mark it at that
there
point.
was a 0 there, but there was no year 0 or 1 or anything
Right.
like that.
But where did the Hebrew calendar, what was the significance of, if we go back now to the year 0, I have no idea.
They didn't really have a 0. They went by the reign of the kings and the judges.
Okay.
So Samuel reigned and you came after Samuel, you reigned, you were there 20 years after Samuel.
I see.
So there was they didn't have a beginning point per se.
Yeah.
It's got to be close though, because if these guys got 4,000 BCE and it's 2012 now,
Yeah.
that's 6,000.
Well, 6,000.
Which is pretty close.
Yeah, actually we are way overdue for the second coming, like 6,000. So anyway, all these people were doing these calculations, including Newton, who was a religious person, and sort of in a weird way, and they got similar results. So because everybody was getting these similar results, people became pretty confident that they were on the right track. Now, in 1701, this is a significant year, because John Fell, who was the Bishop of Oxford, was also the controller of the Oxford University Press, which is, the powerful publishing it. And he had the idea of publishing an annotated version of the Bible with little notes in the margin. And he put this year, 4004 BCE, in this annotated Bible as the year of creation. Okay? So suddenly, this thing, which had been an academic exercise done by various people to calculate the age of the earth, and was to some extent negotiable, once it got in the Bible, all bets are off. It's in the Bible, it's true. Okay? And if you like the dogma that the earth is roughly 6,000 years old, if you want to pin the blame on it, don't pin it on Usher, pin it on John Fell, the Bishop of Oxford, who, by inserting it into the Bible in annotated form, pretty much ensured that people thought, okay, this is it, we got to believe this. Okay? Now, it was only after that that scientific theories of the age of the Earth started to become developed. And one of the things that happened was that given that there was 6,000 years, okay, they thought, okay, now everyone thought it was about 6,000 years old, the Earth. You had to, scientists started wondering, but how did all the features of the Earth come about? You know, you had mountains, you had valleys, the Grand Canyon, you had lots of stuff. Well, maybe at that time, the Europeans didn't know about the Grand Canyon. Well, who would have known that, right? 1700s? They would have had some idea. Grand Canyon. These are major geological features. And the question is, how did they come about in this short period of time? So, in order to explain the geology of the Earth, a theory of catastrophism was created. And this dates back to René Descartes and Leibniz, who said that all these features were created by catastrophes like earthquakes and other things, massive convulsive events that threw up mountains and created ravines and all kinds of things. And that's how all these features came about in such a short time. Okay? But Nicolas Steno was a monk, a Catholic monk, who was also, he used to be kind of a recluse and walk around the mountains of Italy and southern France and so on. And he, in the process, would collect all these fossils. And he started finding fossils of marine life on mountains. Okay? And there's a nice book about Steno called Seashells on the Mountaintop. And to some extent, he's not the earliest, but he was one of the earliest people who carefully catalogued the fossils in the various strata, and got the idea that, you know, the Earth consists of all these layers of geological strata. Okay, and similarly, Robert Hooke, the other scientist, also found evidence for the layers of strata. And so they noticed that the Earth seemed to be built up in terms of layers, and different fossils were found in different layers. But they did not try to use this information to date the Earth. Meanwhile, people were asking the question, well, how did the Earth come about? How was it created? And Immanuel Kant and Pierre Laplace developed what they call the nebular hypothesis of Earth formation. That, you know, there was a gas, and this gas, initially there was a gas, and under gravitational forces, because now Newton's theory of motion and gravity had come about, under the effect of gravity, all these dust particles collected together and formed what we now call the Earth. And that's how the Earth came to be, initially. Now, if that is the case, then there was this French count called de Buffon, who, what he said was, he did this more calculation. He said, if the dust comes together under the gravitational attraction and collapses, combines to form the Earth, then all the gravitational energy that was released as it comes together, because the force of gravity, bring it together, it becomes, speeds up, collapses, there's a lot of heat generated. So eventually, when you get the Earth, it will be a hot Earth because of all the gravitational energy that's stored in there. But then it starts cooling down. It radiates heat. So he tried to do a calculation, a rough calculation of how long it would take for the Earth to cool down to its present temperature. And he got an estimate of 75,000 years. Now, that looks way off. But you got to remember that when he did his calculation, the science of thermodynamics was in its infancy. Thermometers had just barely been invented. So measuring temperature was a tricky business. How he did his experiments and hypotheses were, he would estimate the temperature by holding things in his hand. He would take these spheres, hot things, and hold it, and then put it down and hold it a little later, and try to estimate how hot things were and how rapidly they were cooling using what we would consider ridiculously inadequate instruments. So he got 75,000 years, which is way off. But considering what he was working with, it was not bad actually. You've got to be impressed by the ingenuity of all these people who are doing things a long time ago before we had the equipment now. But although his numbers were nowhere close to what we currently believe the Earth to be, it was very significant because this was the first clean break with biblical chronology. 75,000 and 6,000 are just cannot be reconciled. This is even crudeness of his experiment. This was not some sort of experimental error thing. It was clearly not biblical. Okay, and this caused a bit of a scandal, and religious people demanded that Buffon withdraw his calculation and issue an apology, because he had sort of gone against the 6,000-year-old model. And in fact, not only had he gone against, he had not used the Bible at all as part of his calculation. He had just used what we would call primitive science. But fortunately for Buffon, by the time he was living, about the mid-1800s, the Enlightenment had come along. There was a lot of free thinkers at that time, and there was enough secular pushback against the priest that he didn't actually have to apologize. Okay, his calculation was stood. Any questions about that? Yeah, Tom.
In discussing evolution with fundamentalist college, they seem to use the Grand Canyon, and they have this big story why it could be formed within the last 6,000 years. Do you know how they explain that?
Is it catastrophe? I am assuming it's catastrophism. That it was a sudden.
They use biblical flood geology. The idea that a massive flood, and there is evidence that a massive flood with water moving very quickly in high volume of water can scour out and significantly change the landscape. This happened at you may have heard of the Scablands, and I believe it's in Washington State. The Scablands, which is this really eerie, almost moonscape geologic feature, was carved out in a matter of days when a massive glacial lake, the dam broke, and this enormous volume of water moved out over it and just completely changed the landscape as a result. And that's kind of where they get the idea for, well, if you just picture something on a larger scale, you get the Grand Canyon.
When did that happen?
Well, we know obviously now it happened millions of years ago, but they kind of ignore that fact. No, actually, it wasn't millions of years ago. It would have been, maybe just near the end of the last ice age.
About 10, 15.
Well, no, a little longer than that.
But back in that.
Yeah, back in that period of time.
But they know it happened in days?
Happened in an instant.
Well, I don't. Well, yeah, everybody does. I mean, the geologists will tell you. If you ask any geologist from here, they'll tell you that this event, the dam broke, and in a matter of days, the water just scoured out the landscape.
That Lake
Wasn't even
Bonneville.
actually probably wasn't even days.
Lake Bonneville.
Well, Lake Bonneville's that's a completely
Different
different.
thing.
This
What
is
is
in the
that?
Columbia Basin Plateau,
Yes,
in the high desert, between the mountains.
but that's where they get the idea for. You just imagine that on a grander scale, a larger volume of water, and you get the way they look at it was the flood associated with the global flood, the 40 days, and the flooding that occurred after that. That's what created the Grand Canyon. I mean, if that story were actually true, and that volume of water covered the earth, well, that would be more than enough to scour out, several dozen Grand Canyons.
Yeah, except that there's only about 200 or 300 problems with that.
Yeah, well, obviously there are.
Like the two right angles that the Colorado makes. How you do that and still with one sweep. It's tough.
But most of these are like that. They just assume that there was some major event, cataclysmic event, that created these things. And it was around 1800 that geologists.
I love you, Mano.
What?
I love you.
Yeah, the geologists actually need a lot of credit for the early things. I mean, what they did, because what happened was James Hutton was a British geologist, and he introduced the idea of uniformitarianism as opposed to catastrophism. And what uniformitarianism said essentially was that all these major features, mountains, valleys, ravines, Grand Canyons, all these things were created by small incremental events spread out over a long period of time, not catastrophes. And so immediately the idea became that this was even 75,000 years may not be enough. Okay? Because for all these things to occur by slow, tiny little steps, And the reason they did that was they could see erosion. For example, they could see riverbeds silting up. They could see all these slow processes taking place in real time, even in the space of a few years. And so they extended and said maybe all these big events also occurred by these similar small processes taking place over a long time. So that was the name given to uniformitarianism. And meanwhile, paleontologists looked at the fact that layers, at different layers you have different, you found corresponding layers in different parts of the world, and you also found layers of different fossils at different levels. And they all seemed to suggest to these the early geologists and paleontologists that the formation of the Earth was slow. Okay? And so the idea went back that maybe it was really, really old. Maybe it was an infinitely old Earth again. And then we had Charles Lyell, one of the preeminent geologists of that time, in fact of all time I would say. And he introduced the idea of actualism, which was that the rate of change of geological features was roughly the same through all time. So that was important because if the rate of change is the same, then by measuring the rate of change of anything like the silting of rivers or the way things change, with the way rivers erode things, if that rate of change remains constant, then by measuring how much the total change was, you could calculate how long it took. Okay? And yeah.
Can I inject something?
Sure.
You're in my field now.
Yeah.
Charles Lyell published a 3-volume set on the geology of the Earth in the 1800s. And in fact, it's just an FYI, when Charles Darwin left on the Beagle, he had in hand the first volume of Charles Lyell's book, and it greatly influenced Darwin in his thinking. Anyways, Lyell popularized uniformitarianism, and there's a key phrase that goes with it, which is the present is the key to the past. And the idea that present processes that we see now can be used to judge rates of geologic change in the past, which is what he was talking about, the actualism.
There's another issue here with Hutton, and I believe he was a Scotsman.
He was a part of the Scottish Enlightenment.
Yeah, and he observed the Roman walls that were built and how much erosion took place in that time compared to the rocks, and so he knew that the rocks erosion was much older.
Sure. In fact, Darwin had the first. I'll come to Darwin in a bit when I talk, but by 1850, it was accepted among scientists because of the work of Lyell and all the other geologists of that time that the lower limit to the age of the Earth tends to actually a few hundreds of millions of years old. So they had put a lower limit. It was at least as old as this in order to explain the features of the Earth. Okay? And this was important because it gave Darwin two things. One is the idea of small incremental changes leading to big changes is essentially the same idea in natural selection, in Darwin's theory of evolution. The idea of tiny changes over time accumulating to give big changes. So that was an important, I can't help but feel that Darwin was influenced by Lyell's book to see that this idea was pretty plausible. Whereas earlier people thought of species creation also as one-shot deal. God suddenly created it, the biological equivalent of catastrophism. Suddenly boom, you get bears and you get chickens and you get goats and they just appear. And Eddie Izzard has a wonderful, I'm not sure if you watch Eddie Izzard, the comedian, stand-up comedian, but he has a wonderful bit on this whole business of God creating things, just randomly. And he says, okay, Mali is over there, and the Sri Lanka is over there, and he just creates things, and strawberry jam, and then God just creates all these things out of nothing. But Darwin got the idea that maybe it takes place by slow incremental changes. So that's one idea. The second is the geologists had given Darwin a large window of time now to work with. So there were two things that were really influential for Darwin and Wallace. Now, the opponents of the problem with Darwin's theory of natural selection, and this is where the religious issue started coming back again, with the idea of, even though the Earth had become much longer than 6,000 years old now, at least in scientific things, it didn't cause as much of a problem as the idea that Darwin and Wallace were proposing, that evolution was an unguided process. It took place randomly. You had random mutations and various changes, and then you had natural selection. But that required, it was an unguided process. There was no guiding element putting in a particular direction. So people immediately sensed that this ruled out God, right? Because if you had unguided evolution, then what was God doing? He was doing nothing, and they didn't like that. So in order to undermine the theory of unguided natural selection, scientists, even within the scientists who were religious, tried to bring down the age of the earth, because the shorter the age of the earth got, the less likely that unguided natural selection was possible, and the more plausible that you needed some sort of hidden agent pushing evolution along in a particular direction, what we now call theistic evolution or guided evolution or something like that. So there became this battle between those scientists who thought of unguided natural selection and were comfortable with a very long age of the earth, and those scientists who were religious. Most scientists were sort of religious at that time, who were trying to make the age of the earth younger, because the younger you could make it, the less likely natural selection in its pure form could work. Okay? Lord Kelvin turned out to be the biggest ally of the religious scientists at that time. Now, Lord Kelvin is one of the great scientists of all time, and in fact, he was the founder of the field of modern thermodynamics, really. Not only that, he did terrific work in all kinds of areas. But he was also religious. And he was not happy with the idea of unguided natural selection. And so he did one thing. He introduced physics principles into geological studies. Okay? Up to now, age of the earth, the geologists have been working in terms of calculating rates of change of things and using that to calculate the age of the earth. What Kelvin did was he brought back the idea of Buffon's idea of the earth being created from a cloud of gas and collapsing under gravity, becoming a hot ball, cooling. But now the science was much more sophisticated. They had more sophisticated measuring equipment, they could do much more sophisticated experiments. So basically Kelvin did variations on Buffon's idea, but much better. And so he introduced the idea of thermodynamics and gravity and so on into calculating the age of the earth. So he made the calculations more rigorous. And Kelvin has to be credited with introducing real hard science into this particular calculation. Okay. Now, so he assumed that all the Earth's and the Sun's energy originated as gravitational and mechanical energy in the particles and possibly meteors that preceded its formation. And as they coalesced to form the Earth, this gravitational energy was transformed into heat energy that made the Earth into a hot molten ball. The Earth then gradually cooled and solidified as this heat was slowly radiated away into space. Now he had to make certain assumptions, like the rate of heat conductivity in the Earth and so on. And there were a lot of assumptions that went into this calculation, but the basic ideas were fairly straightforward. And using that, he repeated Buffon's calculations, but more sophisticatedly. And these were the results he got. In 1862, Kelvin published a result that said the Earth was somewhere between 20 and 400 million years. Large margin. Okay? But then in 1868, he did a calculation again, and he got less than 100 million years. Okay? In 1897, he was getting up there in age. He was getting a old guy there, but he got up to between 20 and 40 million years. Now, there were a lot of assumptions in this, and already this was causing problems for natural selection. And biologists didn't like it because it didn't give time for natural selection. Geologists didn't like it because it contradicted what they were getting with their calculations for the age of the Earth. Okay? So people pointed out that there were various assumptions that went into his calculations, and these could affect the age of the Earth by about 50, factors of 50. But Kelvin was, the most eminent scientist of his time, and he carried a lot of weight. And so meanwhile, geologists thought that it was at least 100 million years, that the Earth was at least 100 million years old, and biologists needed at least 200 million years. So around the 1900s, we had very strong competing factions: the geologists, the biologists, and the physicists. The physicists were saying it's less than somewhere in 20 to 40 million years. Geologists said no, and the biologists said no, that couldn't work. Now, physics was the oldest discipline, but by the time 1900 came along, the geologists and the biologists were now also established disciplines. They had their own professional societies, their annual meetings, and they couldn't be pushed around by the physicists anymore. So they stood their ground, and there was essentially an impasse that said with these different schools of thought. Okay. In fact, around Darwin 1880, just a year before he died, remember, just before that, the age of the Earth was getting less than 100 million years old, so Darwin knew that that was going to be a problem. And this is what he said: with respect to the lapse of time not having been sufficient since our planet was consolidated for the assumed amount of organic change, and this object, as urged by Lord Kelvin, is probably one of the gravest as yet advanced, I can only say, firstly, that we do not know at what rate species changed as measured in years, and secondly, that many philosophers, that is physicists, are not yet willing to admit that we know enough of the constitution of the universe and of the interior of our globe to speculate with safety on its past duration. So Darwin was saying essentially, yeah, things look bad for my theory. All I can say is we don't really know this well enough to say definitely. And this was about a year before he died, and he never actually lived to see the resolution of this issue. So to some extent, I have to think that Darwin went to his grave being a little concerned about his theory of evolution, because it seemed like the time was not on his side. I mean, not that he was dying, but time in terms of the time, age of the Earth was not on his side. Okay? That brings us to the 20th century. And things started moving very, very rapidly. 1895, we had the discovery of radioactivity by Marie Curie, that elements have radioactive decay, and in the process produce heat and other forms of energy. Remember, Darwin was doing his work, although Mendel had developed his idea of genetics before, Darwin was unaware of it, because Mendel published it in an obscure journal and nobody seemed to know about it. But in 1900, Mendel's work was rediscovered, and people realized that this was the element of heredity that Darwin was unaware of. So they incorporated it into his natural selection. Meanwhile, people were using the radioactivity to measure the ages of rocks, and they started, that was open season on rocks. People were finding rocks everywhere and measuring the ages of them using radioactivity, and by 1905 their oldest rock was 141 million years, and by 1911, just about a dozen years after Kelvin's thing, we already had 1.64 billion years as the oldest rock. Okay, so clearly, and by 1920, what they call the neo-Darwinian synthesis and population genetics became the standard paradigm for evolution. So now, by 1911, the age constraint disappeared. It was clear that the Earth was about billions of years, more than a billion years old. There was no problem with having enough time for natural selection. So Darwin was rescued, but as I said, he was already dead. The next problem, that the Earth became a little too old. Because as they started finding more and more rocks, by 1935 it had gone to 1.9 billion years, a few billion years by 1921, I should have changed the order. By 1927 it was somewhere between 1.6 and 3 billion years. In 1956 they found a rock that was 3.45 billion years old, and the present, the oldest rocks that we have is about 4.55 billion years. Yeah.
If I may inject, that 4.55 billion years old is not based on the age determination of the rocks on Earth. It's based on age determination of meteorites. The oldest actual rock dated on Earth to date is 3.94 billion years old. But that's based on the age of meteorites, and the Earth has to be at least as old as the meteorites.
Okay, but meanwhile, there was another field of research measuring the age of the universe, trying to do that. And Hubble was doing that work. And in 1929, Hubble's calculations said that the age of the universe was thought to be only about 2 billion years old. So you had, around the 1920s and 30s, you had a dangerous situation where the age of the Earth was becoming older than the age of the universe. And that was a problem, as you can imagine. Okay? So I'll quickly go through the Big Bang chronology. So when people try to reconcile this, 1915 there was the general theory of relativity with Einstein, whose model was of a static universe. In 1922, the model changed and people realized that the universe was not static. It seemed like it was expanding. Georges Lemaitre proposed the Big Bang. He didn't call it the Big Bang, that name came later. But the idea of a universe created in a dense explosion and spreading out, and velocity of the galaxies being proportional to the distance came about. 1929 was the initial Hubble data. In 1948, we had the steady state and Big Bang nucleosynthesis, and that model said that the universe has been around forever, infinitely long. And in 1965, the cosmic microwave background radiation was discovered by Prentice and Wilson, which essentially ruled out the infinitely long steady state universe, and we went back to the initial Hubble universe. Okay? So again, that was about, I'll just jump through the Hubble thing. So currently, the theoretical model for the universe, what?
She has the Big Bang theme song in her head now.
Oh, the TV show?
TV show.
Yeah.
So the current theoretical model is the universe is governed by Einstein's equations of general relativity. The current state of the universe is matter dominated. That is, the energy contribution of pure radiation is negligible, and the universe is flat. The total density of the universe is equal to its critical value. Technical aspect, it basically says that the universe, the curvature is zero, and the Einstein's equation of general relativity say it can be positively curved, negatively curved, or flat, and what we think is that it's flat now. And basically, our best estimates of the parameters is that matter, the normal matter that we have, that the universe is made up of, makes up just 4% of all the matter in the universe. So-called dark matter, which is matter that is still massive, but not like the normal matter that we are familiar with, it's an unknown form of matter, makes up about 24% of the universe. And what they call dark energy, a form of energy that again is not something that we are familiar with, that takes up 72% of the universe. So the familiar things that we are used to makes up only 4% of what we consider the mass of the universe. 96% is stuff that we are still searching for, though we have good reason to believe based on the evidence that it exists. So the age of the universe, this is the equation for the age of the universe. It's a very simple equation when you think about it. I mean, if you don't mind the inverse hyperbolic tangent, but you know, any pocket calculator now has that formula. So if you know the omega lambda is the dark energy density divided by the total energy density of the universe. H naught is the current value of the Hubble constant. So if you just know those two numbers, you can take out your pocket calculator and calculate the age of the universe.
Of course.
Yeah?
Simple.
It's simple. I know. I mean, when I look at this equation, I think, this is amazing.
I'm getting 4 months. I think I'm missing a square root.
You know,
You're making the same kind of blunder that Einstein did.
Probably, yeah.
You need to insert the
Constant.
you need to insert the constant in there, the
Oh, yeah, 13.7.
the cosmological constant.
you know, sometimes I talk to religious people and they say, you know, the trouble with you scientists, everything for you is sort of mundane. You don't have a sense of wonder or awe at this transit. And I look at this equation and I say, just look at this equation. We are a tiny speck on a tiny planet in a tiny part of the universe who have lived for just a tiny part of the time, and we have advanced our knowledge so much that we can write down in a simple one-line equation the age of the universe, which existed, came into being long before anything else. And I think if that doesn't make you feel a sense of wonder, I don't know what it is. What will make it? I mean, I just think that that's amazing that we can do this. And so then people have sent up satellites, the Wilkinson microwave anisotropy probe has measured this, and they've got these as the best fit numbers. And when you plug those into that equation and in your calculator, and you get 13.7 billion years old. So that's the age of the universe. Okay?
Mano, you mentioned earlier a problem they had early on when they were getting the age of the Earth at 4.5 billion, but the age of the universe at 2 billion.
2 billion.
Remind me, wasn't there a similar kind of scare
with the age of stars?
A decade or so ago,
Yeah.
Where they got the age of the stars was older than the age of the universe?
Yeah, they had a similar problem. No, basically they were measuring the ages of the stars, and they found that some of the ages of the stars were getting dangerously close to being older than the age of the universe. But that got resolved. I forget how it was resolved, whether the age of the stars got corrected or whether the age of the universe got more. I forget.
Wasn't it they found that there was some kind of error in their measurement that led to age of the stars being older than they actually were?
I think that's what it was. In the case of Hubble, when he got 2 billion years old for the age of the universe, they found a systematic error in the way they were calculating distance. So that's what Hubble was off by, because measuring the distance to the stars was difficult. And measuring the age of the stars was also difficult. You had to use various models. So I think as time goes by and our models get better, we have made better calculations of the age. But right now there is no controversy as far as we know. Because the oldest stars that they have detected, I think, were about 800 million years after the Big Bang, but nothing younger than that. Yeah.
I think the big problem, if I recall, was the figuring out the exact value for the Hubble constant. And at one point, they were looking at a value for the age of the Earth as going, or the age of the universe as going between a range of 10 to 20 billion years.
Yeah.
But once they got a little bit better handle on the Hubble constant, then they were able to start narrowing it down to 13 to 15, and then finally to...
Yeah, hasn't the Hubble constant over time, based on has ranged between like 50 and... I remember it was as high as 100.
Right,
yeah.
Right. That's the rate of expansion or the acceleration.
But it was high at one time. And if it gets high, then the age gets low.
Oh, right.
So there is, if the Hubble starts getting higher than what it is now, much higher, then there would be a problem, because we would have...
The irony is that the Hubble constant was pretty much aided by the Hubble telescope. The stuff that they were able to see with the Hubble scope enabled them to figure out an exact answer for the Hubble constant.
Coming back to the... Now, how has religion... I've spoken somewhat about how religion responded to this. But typically, the interplay of religion and science has been the following. Step one. First, religion opposes any scientific finding that contradicts the dogma. Okay? So if science comes along and says there's something that opposes the religious belief, they say, well, you must be wrong, we don't believe it, and so on. Then, after time, they can't deny it anymore. It becomes so commonplace that, except for the really determined dogmatists, then what they do is they revise the dogma to accommodate the new result. And things that were considered hard facts earlier now become metaphors. Okay? And so religious texts become metaphors. As someone said, in science, when a theory turns out to be wrong, it's discarded. In religion, when something turns out to be wrong, it becomes a metaphor. Right? So, yeah.
What's the reaction from all the other religions in the world to the science?
Most religions didn't have a sort of, at least, don't have a definite date like Christianity has. I mean, they have a cosmology, but it doesn't have a definite date. Now, there are elements of Islam where they think that, they reject evolution, they reject all this stuff. But by and large, Hinduism, Buddhism definitely has no problems with this.
But apart from just the age of the universe, other religions have their own stories, and science may contradict some of them.
Yeah.
Don't they have don't those other religions have some kind of reaction?
They do. Like most people, they sort of compartmentalize. They really think, okay, they do the science by day and their religion by night, as it were, and don't try to reconcile it. That's what they do. Most people, that's what happens. The people who get into trouble are the people who try to reconcile it. And when you try to reconcile science with religion, you either become an atheist or you become a very dogmatic religious person. So they revise the dogma to accommodate the new result. Then the third stage is interesting. Some of them claim that the religious text actually predicted the result, which they denied earlier, and which is proves that it must be God's word. For example, here's a statement from a Catholic website, which has the audacity to say the church has always agreed with scientists on matters such as the age of the earth and the authenticity of the fossil record. Yeah.
The interesting thing about that statement, though, is that even assuming it was true, that means the church contradicted itself.
Yes.
Because they agreed with scientists who
disagreed with each other, exactly. But
I'm pretty sure, didn't the Catholic Church, I don't think it was right away, but eventually, step 3 there, claimed the Big Bang was predicted by the Bible because the Big Bang actually verifies that there was a single creation event?
Yeah.
That's correct.
And in fact, I'll come to that. With Galileo, let's take specific cases of this model. Okay? Galileo. In 1663, the Catholic Church put him on trial. 1992, is 329 years. The Catholic Church says he was right and apologizes for his persecution. Then Pope John Paul II says Galileo sensed in his scientific research the presence of the Creator, who is stirring in the depths of his spirit, stimulating him, anticipating and assisting his calculations. So God was with Galileo from the get-go, pointing him in the right direction.
Well, why wasn't he with the Catholic Church then?
You're not supposed to ask those questions. You're just supposed to take each
Well,
period.
the Pope is infallible except when he's not.
Was it with them when they were showing him the torture instruments?
Yeah.
In the case of Galileo, when he first was backing up, going back to Copernicus, the church ruled that it was hypothetical, not theoretical. Theoretical means that they got proof.
Right.
And so you could use it, but you couldn't claim it to be the truth. Galileo, for some reason, was making these telescopes, but he looked at the sky with them. Nobody else did because everything to know about the sky was known. And then he discovered Jupiter's moons and so on. And so he wrote a book. And this created a real problem. But the Cardinal Barberini defended him with the statement that the Bible tells us how to go to heaven,
right,
not how the heavens go,
right,
which is really the best attitude to have. But Galileo embarrassed a Jesuit priest, the Father Schneider, who went back to Germany, but later on he was called down to Rome when Barberini became Pope. He became Pope Urban VIII, and at that point, Galileo thought he could write his book about the starry messenger, and he had a guy in it, Simplicio, who was listening to both sides of the story, and Schneider convinced the Pope that he was Simplicio and Galileo was calling him a simpleton.
Right.
And so they brought him down, and that's what the result of all that persecution was. The Pope himself forgot what he said about the Bible teaches us to go to heaven, not how the heavens go. And so in 92, this is what they went back to. He was right all along, but the Bible tells us how to go to heaven.
Right.
Well, there's some evidence, and some historians will argue this case, that part of the reason Barberini Pope Urban came down on Galileo the second time around, because Galileo didn't say anything different from what he had said earlier, although he presented it different. But by that time, the church was not only having to deal with this science issue, but they were also having to deal with the Reformation.
Yeah, the Reformation.
Yeah.
And the Pope was in a position where, we can't go any further with it. We have to basically retrench, regroup, and I think Galileo got caught in that.
Yeah.
Yes,
it is a complicated story.
And Urban, by the way, made all the other bishops and so on get rid of their mistresses. Of course, he kept his, but he reformed the church, you could say, because prior to him, what brought on the Reformation, I went to Catholic school and I was taught that it was something else. but it was really that they were really, had reached a real low
Right.
with that. They were really, yeah, doing.
But now the second example I want to get to is evolution. Again, first they opposed it. In 1996, Pope John Paul II says, the convergence in the results of these independent studies, which was neither planned nor sought, constitutes in itself a significant argument in favor of the theory. So they've come around to it. And in 2010, the Pontifical Council for Culture says, while the Church had been hostile to Darwin's theory in the past, the idea of evolution could be traced to St. Augustine and St. Thomas Aquinas.
Right. Of course.
Okay. So again, finally they take credit. Now I can make some future biblical predictions on this. Okay. One is, some people have looked at the universe and tried to calculate. The computer scientists especially have tried to see how much information there is in the universe, and looked at the universe as information and how information has been evolved over time. And so there has been this model of trying to understand the evolution of the universe as growth in information. And religious people have said, but the Bible anticipates that too. I've heard people say this. Because look at John 1:1, it says, in the beginning was the Word. And what is the Word but information? So the Bible anticipated this idea of the universe as being information. Okay? Now we are coming to the idea of the multiverse. And the fact that this universe, and as it was pointed out, the Big Bang was assumed because they looked at the Genesis story and said, okay, that looks like the Big Bang theory. Of course, but now there's coming out the multiverse, which says that we are not the only universe. Actually, the universe might again be infinite if you read some of the latest cosmological theories. We have a local universe, but a local universe is just one part of a continuum of universes, and that there is no such thing as the beginning of the time. It was just always there. And I suspect that if the multiverse gains ground, John 14:2 will be pulled out, and you heard it here first, folks. Okay? This is my prediction. If the multiverse becomes the accepted scientific theory, John 14:2 is going to be big. Okay? And there's always divine inspiration. So here's another thing from the Catholic website. The question about the origins of the world and of man has been the object of many scientific studies which have splendidly enriched our knowledge of the earth, age and dimensions of the cosmos, the development of life forms and the appearance of man. These discoveries invite us to even greater admiration for the greatness of the Creator, prompting us to give Him thanks for all His works and the understanding and wisdom He gives to scholars and researchers. So whatever scientists find, they're going to say.
Yeah, but how does the Catholic Church reconcile the Adam and Eve story with evolution? Have they ever been asked?
Metaphor.
If you believe in evolution,
It's a metaphor.
Adam and Eve be true.
It's a metaphor. But the Adam and Eve is a really serious problem. It's true, sophisticated people say, well, it's just a metaphor. But it's not.
It can't be a metaphor because they knew Jesus.
Exactly. If it's a metaphor, then what did Jesus die for? What happened to original sin? Why did Jesus come and die to save us from our sins if there was no original sin to begin with? And there can't be original sin if there was no Adam and Eve. Some people, there's been a complicated thing. There are some people who say that evolution occurred, but at some point humans came into being, and those first humans went into this Garden of Eden. And they are the ones who suffered the fall. But of course, we know how to calculate, and there was never there was a bottleneck in evolution, but the bottleneck involves at least hundreds or even thousands of people. There wasn't a single couple. That's one thing. So that's a serious problem. The other problem is, if you take that model seriously, people believe that all the suffering in the Bible, all the suffering that occurs in the earth, was because of the original sin. Before the original sin, people lived forever, there was no pain, there was nothing, right? But if evolution happened, and the humans came along later, then why did the dinosaurs die? Because they were before Adam and Eve, right? So now, William Dembski, some of you may be familiar with him from intelligent design days, smart guy. But very smart, but comes up with these theories. So he tried to explain this. First of all, he tried to say, okay, maybe the earth has been around for a long time. And what he said was, well, there's no reason why God can't go back in time. So what happened was, God was punishing the dinosaurs by making them extinct because Adam and Eve much later were going to commit sin. So the cause and effect was reversed. So the cause happened after the effect.
Could not possibly make any sense to anyone.
Yeah.
It didn't make sense even to Dembski's colleagues at the seminary that he was working, because other people jumped on him. Not because this theory made no sense, but because he was even challenging the idea that the earth was more than 6,000 years old. And the idea of God punishing preemptively the dinosaurs, one of his colleagues wrote a very sarcastic review of his book and said it would be like a father punishing his son every Sunday because he knows that the son is going to do something wrong the coming week. So you might as well get the punishment out every Sunday in advance. Yeah.
I was just going to say, within the story of Adam and Eve, even without taking it as a metaphor, even if you try to take it seriously, it never explains like how there was any other people. I mean, it has Cain and Abel, and then Cain kills Abel, but then God gives Cain a wife, but it doesn't say where that.
There's another son, Seth, also comes along. But where did they all turn out to be men. So, but there's some weird stuff. If you go a little beyond, there's mention of other people. There's mention of some sort of giant race of humans who were there. There's all kinds of weird stuff that people never get to, because most people read the first 2 chapters and think, okay, I know what the Genesis story is. You go a bit further, it's really weird.
There's also mention of other civilizations.
Yeah.
In the beginning, with like Adam and his like immediate family, like there's all of a sudden these new.
Right. And the fact that all these questions exist, and as soon as you start peeling apart these things, the whole structure falls apart. Carl Sagan had a nice thing. The fact that religions are tough. Either they make no contentions which are subject to disproof, or they quickly redesign doctrines after disproof. The fact that religions can be so shamelessly dishonest, so contemptuous of the intelligence of their adherents, and still flourish, does not speak very well for the tough-mindedness of believers. But it does indicate, if a demonstration were needed, that near the core of the religious experience is something remarkably resistant to rational inquiry.
And they call Richard Dawkins a new atheist. That's pretty some tough language.
Yeah, Sagan was pretty tough. I think he was gentle in his manner, and he smiled a lot, and he said it nicely. People didn't get so mad, but he was really tough. I mean, he was, you're exactly right, much more tough than Dawkins. I'd like to end with a couple of cartoons. Yeah.
About the multiverse.
Yeah.
Isn't that concept sort of outside of science?
No.
But separate universes, if there are other universes, they're separated from each other. There's no way of one to measure.
No, you can. People are developing models to see, because in the early days of these early universes, there might have been some overlap, and they're looking for anisotropies in the cosmic microwave background that might indicate that at some early point in time, the universes were cut. So these people are actually investigating this. It's not totally.
So they were overlapping one point, but they're separate now.
Yeah, the universes are created as bubbles, out of bubbles in existing universes.
Okay.
And then they grow and you're inside. Okay, how many of you know? Yeah.
One question.
Okay, question.
No, I was just going to answer to what you said. If you go back to the original Adam and Eve story, Adam and Eve were the beginning of God's chosen people. There were many other civilizations. At first, there was actually Lilith, and Adam rejected Lilith because she wanted to be on top for sex.
What was that about?
Huh? Yeah, that's because it got taken out. And then he rejected Lilith, and then Eve became the mother of the chosen people.
I'd like to end with a couple of cartoons because we're running out of time. How many of you are familiar with Jesus and Mo, the cartoon strip, online cartoon strip, comic strip? There's a great comic strip called Jesus and Mo. And the premise is that Jesus and Muhammad share an apartment somewhere in England.
Yeah, right.
They share an apartment somewhere in England, and they actually share a bed also, but there's no indication that anything goes on other than sleep. I mean, but they spend a lot of time in their local pub, where the barmaid is an atheist. So a lot of the humor is Jesus and Mo either talking to each other or talking to the barmaid, who is never shown. She's just a voice, disembodied voice. And occasionally they're joined by Moses, who's a buddy of theirs, but doesn't actually live with them. But anyway, Jesus and Mo is a very funny comic strip. It's online. Just say Jesus and Mo and you'll find it. So here's a comic strip that illustrates something what I'm saying. I'm not sure. Can you see it? Okay, here's Mo. If you can't see it, can you see it at the back? Oh, okay, I'll read it. I'll read it. So here's Mo. This is Mo showing. He's saying and he's they're in the pub. The Big Bang, atomic particles, the structure of DNA, all these discoveries are foreseen within the Quran. And this is proof of its divine origin. That's the first panel. The second panel, the barmaid says, so according to the Quran, what's the next big scientific discovery going to be? And Mo says, it doesn't work like that. First the discovery is made by science, then scholars look in the Quran to find words that foretold it. So then the barmaid said, well, isn't that great? Be sure to thank Big Al for giving us such a useful resource next time you speak to him. And then Mo says, is she being Islamophobic? And Jesus says, sarcastic, I think. And he says, who's Big Al? He's not there. Then the second cartoon is Jesus and Mo are in bed reading. This is what they do a lot. If this is, and Jesus says, Jesus is reading the Quran. And he says, if this is supposed to be the perfect word of God, how come it gets so much wrong? And Muhammad says, like what? And Jesus says, like this bit that says man is created from a gushing fluid that proceeds from between the backbone and the ribs. And he quotes the surah. And then Jesus says, you do know where sperm comes from, right? And Mo says, aha, that is actually amazing proof of the Quran's divine origin. And then Mo continues, modern embryology reveals that the sperm producing organs begin their development in the region of the kidneys. The Quran anticipated this discovery hundreds of years in advance. And Jesus says, you're talking bollocks, aren't you? And Mohan said, yeah, I am indeed. So that's how religion works. Thank you.
We have time to take a few general questions that don't, could be on this topic or anything.
Singham was spoofed a lot of times by Johnny Carson, billions and billions. I just got finished reading the Gifford lectures as presented in the posthumous book, The Varieties of Scientific Experience. And all the times he's talking about those kinds of numbers, he goes to the trouble of saying like 5,000 million years rather than the simpler billions. Why did he do that?
Well, the British don't use the word billion the same way we do. We use billion for 1,000 million. The British use it as million. So when Gifford lectures were in England, right? So he was probably, if he said billion, they would think it was 5 million. So I'm guessing that's why he said 5,000 million.
Just out of curiosity, that equation that for the age of the universe, I'm curious to see the derivation of that. I'm baffled by it's a hyperbolic, the inverse hyperbolic tangent. Do you have a source for a natural derivation of that?
I have a derivation of that.
Oh, okay.
If you give me an email, I'll send you a PDF of the derivation.
How do you know where the argument comes from? Like, I know a few geologists, friends that say that like carbon dating is inaccurate and all that stuff. Is that like something you hear commonly in this argument about Earth, like that it's just like inaccurately dated by radiation or carbon dating or whatever?
Yeah, I mean the carbon dating, they do say that it's inaccurate, but what you can have, there is no fact that you cannot explain by some crackpot theory, provided you are willing to put in enough auxiliary hypotheses. Okay? So for example, you could say that we don't know that the rate at which atoms decay is a constant. Maybe things decayed faster long time ago. That the rate of decay, the rate at which the rate of decay occurs changes with time. So that gives you an extra parameter to play around with, and you can make things much shorter by doing that. There are other people who say, well, the carbon radioactive thing depends on the rate at which it is formed. For example, carbon-14, which is used to measure the age of a lot of trees and stuff like that, 5,000 years. Anything within the range of 5 to 25,000 years, you can use carbon-14. It depends on the amount of carbon-14 that occurs naturally in the atmosphere. Now, we assume that what it is, it's created normally. But if you're a religious person, believe in a young earth, then you believe in the great flood, right? The huge rain for 40 days covered the earth. Where was this water before? Well, they say the water was from this canopy. It was up in the sky, and because it was up in the sky, less sunlight came through. So those days, less carbon-14 was produced because carbon-14 is produced by the interaction of the sun and the various atmospheric effects. So the carbon-14 was produced in much smaller quantities earlier. So the reason we see such few decay products of carbon-14 now is not because it has decayed a lot, which requires a long time, but because it was very small amount was created then, which makes it a short time. See what I'm saying? So if you are willing to add various hypotheses, you can salvage almost any theory you want.
If anyone's arguing with you about the age of the Earth and using errors in carbon-14, you first need to back up and give them an education, because carbon dating is not used to date the age of the Earth. Carbon dating is only good for out to 50,000 years. After that, it is completely unreliable. The age of the Earth is based on dating of potassium to strontium. No.
But they are talking about a 6,000 year old Earth, so carbon-14 is great for them.
Well, yeah. But the point is that they're using as an argument a radioactive isotope that's not actually used by geologists to determine the age of the Earth. Other isotopes are used, such as uranium, which has a half-life in the one of them has a half-life of nearly 4 billion years. It's other isotopes that are being used, not carbon.
I understand that about it. 5 different methods,
And the other thing,
and they all have a pretty close agreement.
Yeah, the way that they know that they confirm that the age of the Earth from these isotopes, every single isotope that is used has a margin of error in it. So if you pick on just one of them and say, okay, well, there's a 10 or 20% or whatever the error might be in this particular isotope, you might be able to make an argument. But what they're doing is they're, more than likely intentionally, leaving out the fact that they don't rely on just one isotope. They determine the age of a particular rock with one isotope. They determine the age of another sample of that rock with a different isotope. And what they find is that despite the margins of error, I think there's 5 different ones, all 5 of them give you ages that are nearly identical. And it's the combination of the 5 isotopes that establishes the age of the Earth.
There's a question?
Age of this theory you are discussing about age of the Earth on the Western theories. Are there any theories on the Eastern or any other religion?
I don't think so, because I've not seen any. And remember, much of the impetus for this was Jesus and the coming again. Okay, that required great interest in the date of when the earth was created, and so that they would know when Jesus would come again. Most of the other religions don't have that messianic anticipation. I mean, they have a sense that the earth, maybe they believe is old or not, but there was not, for example, in the Buddhist scriptures, there's, in fact, his disciples, when they asked the Buddha, where did the earth come from, and how, he resolutely refused to answer those questions, which I think was a very smart move. He just said, go and figure it out for yourself, basically. Don't expect me to give you these answers. And because if he had said anything, that would have become Buddhist dogma. So actually, Buddhists have a lot of flexibility. Hinduism, I don't know anything in their scriptures that suggests that they thought that there was a specific age. Yeah.
In the Jainism, we can see these ones.
In the what?
Jainism.
In Jainism. Do they give a date?
Not the exact date, but they discuss about the eras and change of evolution, how it happened.
Yeah, but none of them give a sort of date and say the earth is now so many thousand years old. As far as I know, none of them, it wasn't an important question for them. It didn't seem, nothing seemed, whereas Christianity was an important question because of the second coming of Jesus. And that's why they devoted so much energy to this whole question.
Would we have arrived at the point of knowing something had there not been that impetus?
You mean, yeah, I think the idea I think yes, we would have arrived at it. Because once modern science came around, these questions became interesting. And they're interesting for their own sake, not just because of religious significance. Remember that the scientific investigation of these came only around after, say, 1800s, 1800s. Before that, because then only people had the tools to make a reasonable calculation. Before that, they didn't have the equipment or the tools to do that kind of calculation. Only the religious people had an interest and some sort of tool, which is the Bible. I mean, you may say it's not a good tool, but it was a tool that they used.
I'd say when it came by earlier because of pagans of the 300s. Before the Dark Ages happened, they were very interested in science, and when the Christians pretty much totally annihilated religion at the time, and became Dark Ages, and science really wasn't allowed to do anything without being called pagan.
The Romans were way ahead on all sorts of medicine and everything. And when Christianity came in, there was a competition. They give it 313, but it was actually another 250 years before they wiped out Jupiterism. And there was these arguments, which we know went on, even though the Catholics, or the Christians, destroyed the Roman literature. We know it went on because the Christian literature is giving the answers to the Jupiterians. And this sort of thing happened so that we destroyed a lot of knowledge when Christianity came in. It just burned all those books and preferred to rely upon ignorance and Bible.
I don't start with a big thing, but I think he's slightly overstating the case. I don't know that the Four Humors was really all that advanced as far as medicine goes.
What's that?
I'm not sure how convinced I am that Roman medicine was all that advanced.
Oh, there's a lot of it. In fact, most of the instruments that we use to do, like the scalpel and so on, were already invented by, I forget the doctor's name.
Galen, probably Galen. But but I think Peter's right. I mean, they did have something. I mean, they were not, but it was not very sophisticated. I mean, even if you go in my building, there's a Dietrich Historical Museum that they talk about the early things, and makes you glad that you didn't live at that time because it was pretty brutal.
We another little issue that sort of came up recently for me. What happened to determine Easter? The early Christians had to go to the rabbi to tell them when to celebrate it because it was supposed to be the first Sunday following the first full moon following the vernal equinox. So they had to go to the rabbi, who was kind of an astronomer, and he would tell them when to celebrate. Well, to get over that, to escape that, what they did is they said, well, the vernal equinox occurs on March 21st. It actually can occur anytime from the 19th to the 22nd. So this is the way it was. When I was in high school, I saw the earliest Easter, March 25th, and the latest Easter, April 25th, and that was the extent of it. Well, recently I was reading in the paper that, it can come earlier than that. In fact, I think it did. And it can come later than April 25th. And so what I think has happened, and I sort of figured it out a little bit, they abandoned March 21st and went by the actual vernal equinox.
Okay.
Just convenient, without telling anybody that this is how it works.
Got time for one more quick question, anybody? I guess not. All right.
Just one thing that I was curious about. Since Kelvin died a little bit after the discovery of radioactivity, and the fact that now you've got all of the stuff that's scattered throughout the Earth, it's providing a lot of energy to heat up the Earth. Did he revise any of his calculations?
This is a topic of some debate. You're right. Kelvin's theory got shot down because when they discovered that the new source of radioactivity is a new source of heat, his model that the Earth was just a passive cooling thing, single object that cools, and his calculations were based on that. With radioactivity, they suddenly realized that there's heat being generated at the same time. So his calculations were off. And that came at the tail end of his life. there is no published work that suggests that Kelvin revised his theories. There are some stories that at a seminar that he attended when he was very old, where one of the speakers spoke about radioactivity and how...
Arthur Holmes.
Was it Holmes? Arthur Holmes.
Geologist Arthur
Arthur Holmes was, okay. And that he acknowledged that his calculations were wrong, but that story is a bit apocryphal. I'm not sure that it's been very confirmed. So it's a bit iffy. But it's true that his end of his life overlapped with the discovery of radioactivity and the basic collapse of his theory.
All right. A few quick words. I'm going to make a general